So for this video, I will be discussing on how to solve first-order Bernoulli differential equations, or also called as FOBDE. So the definition of a FOBDE is a DE, or a differential equation, with standard form dy over dx plus y p of x is equal to y raised to n q of x. So as you can see, the only difference between a FOBDE and a FOLDE when it comes to, or in contrast to a FOLDE when it comes to the standard form, is that a FOBDE, for example, a FOBDE in y, has an extra y raised to n. So this means that since this DE has a y raised to n, where y can take numbers such as 2, 3, and 4, or any natural numbers, then we can say that this DE is actually, or a FOBDE is actually, not linear in nature or by nature. Another form of a FOBDE is dx dy xp of y is equal to x raised to n q of y, where your dependent variable is x and your independent variable is y. Now, when it comes to the general solution for a FOBDE, there are two general solutions similar to what we have had on FOLDE, which is that the general solution for a FOBDE in y, in our case, would start with a function of x. So we started with a function of x right here. For a FOBDE in y, for our general solution, we would also start with a function of x. So we will start with phi of x. Now that we have the x here, the one that is multiplied to x is actually the other variable, which is y. But in our case, for the general solution of a FOBDE, there is an extra exponent, y minus n. Integral of y minus n, or 1 minus n. So these are the extras that you will have to take note of when it comes to a FOBDE in comparison to, or in contrast to, a FOLDE. 1 minus n. Then the same goes, you have a function of x right here, so phi of x, q of x, dx. So this is the general solution for a FOBDE in y, where phi of x is equal to e raised to the integral of 1 minus n p of x dx. So in contrast to our general solution formula for the FOBDE in y, we also have the general solution for the FOBDE in x, which is given by phi of y x raised to 1 minus n is equal to integral of 1 minus n phi of y q of y. dy, where phi of y is equal to e raised to the integral of 1 minus n p of y dy. So that's it. That's all the formulas that you have to take note of. The standard form for the FOBDE and the general solution for the FOBDE. So for our first example, let's have y prime plus xy is equal to xy cubed. So the first step when it comes to solving a FOBDE is to first be able to make it look like a standard form, or make it in comparison to the standard form, it should have that form. So you first make this given example into the standard form. So in order to do that, let us first rewrite y prime as dy over dx. Now in our case, what we need to have for a dy over dx or a FOBDE in y is that first we need this part right here without being multiplied to any coefficient or any variable. So dy over dx should be by itself dy over dx, then added actually to y. So where will that y come from? So this y right here, actually we can factor it out, and then the x right here we can actually make it like this, so that it looks like we're multiplying y to a function of x. Y times the function of x, which is what we want for our standard form. Y times the function of x. Then when we check the right side of the equation, this is actually now the standard form of a FOBDE. But if you want to be particular, very particular, then we can actually rewrite this as dy over dx plus y times x is equal to y cubed times x, where you have y multiplied by a function of x. So we have p of x right here. This is p of x, and then y raised to n, where this is your n, multiplied by q of x. So this is now a FOBDE in y. Now we need to find the general solution for the FOBDE in y. The way that we're gonna find this, or how we're gonna find it, is that we're gonna use the general solution formulas. So the first general solution formula, or the general solution formula for a FOBDE in y, is given by phi of x y 1 raised to 1 minus n is equal to 1 minus n phi of x q of x dx, where phi of x is equal to e raised to the integral of 1 minus p, or 1 minus n, sorry, times p of x dx. Now what we're gonna do is basically just first solve for phi of x. So this is how we do it step by step. First is that we make it look like a FOBDE, or the standard form of FOBDE, which we've already done. Then next we find the general solution, but before we use the general solution formula, we have to find phi of x, since we won't be able to complete the general solution formula without phi of x. So we first need to solve for phi of x. Okay? And phi of x is equal to e raised to integral of let's substitute what we have. So 1 minus n, we've said earlier that n is actually equal to 3, so we can write this as 1 minus 3 times p of x. So p of x is actually x, this function of x right here. So we can write this as e raised to the integral of negative 2x, or we can actually factor out or take out the negative 2. Then what we're gonna have inside the integral is just x dx. Then this becomes e raised to negative 2. The integral of x is just x squared over 2 by the power rule. So that's it. And we're just gonna have to simplify this. So we have phi of x is equal to e raised to negative 2 or negative x squared. And that's it. We found phi of x. Now that we've found phi of x, let's now solve for the general solution. So the general solution is given by e raised to negative x squared. We're just substituting what we have. So phi of x is just negative x squared, e raised to negative x squared. So we're substituting that right here. E raised to negative x squared times y raised to 1 minus 3, right? Our n is 3, is equal to 1 minus 3 times your phi is e raised to negative x squared, and your q is, what's your q? That is x dx. So now let's just simplify this. We're gonna have e raised to negative x squared, y raised to negative 2 is equal to 1 minus 3. You can actually take this out. We have a negative 2 right here outside the integral sign. You can put that right there. Then you're gonna have negative x squared, or we can rewrite this actually as x raised to e, or x e raised to negative x squared dx. Now what we're gonna do is that we're gonna have to be able to integrate this part right here. So how do we integrate that? We can actually use u substitution. So if you can see, you can actually use u substitution right here. Where you can actually let negative x squared be your u. So when we let u be equal to negative x squared, du, or the derivative of negative x squared, is actually negative 2x dx. But why do we want this? Because we know that negative 2x, although, or we can actually see negative 2x right here, negative 2 and x, negative 2x, we can actually see that right there. So given that, we can rewrite our function or our equation into something like this. Or sorry, we can actually rewrite this as u e raised to u du, right? Negative 2x became du. Now, or sorry, this actually just becomes negative 2x dx becomes du, and u is negative x squared. So we're just gonna have e raised to u du. Now, when we've integrated this is actually just equal to e raised to u plus c, where your e raised to u, you can actually write this as e raised to negative x squared plus c. So now we have e raised to negative x squared y raised to negative 2 is equal to e raised to negative x squared plus c. Now we can divide actually both sides by e raised to negative x squared, or multiply both sides by e raised to positive x squared, so that we can cancel out the 2. So if we multiply both sides by e raised to positive x squared, this actually just becomes y raised to negative 2 is equal to 1 plus c e raised to x squared. Okay? And now you can also, if you want, you can also multiply both sides by let's say y cube, so that you have a positive y right here. But this is fine as your final answer. Y raised to negative 2 is equal to 1 plus c e raised to x squared. This is fine as your answer. But if you want to, you can actually multiply both sides by y raised to positive 3. So you're gonna have y is equal to y cube ce raised to x squared. You can have this as well. So this is also an answer. So that's our general solution for this given problem. Okay, so let's have another example. We have x dy over dx plus 5y is equal to 2x squared y raised to 4. And we're gonna have to find the particular solution, because we have a given initial value, or we have an initial condition. Y of 1 is equal to 3. So our first step would be to make a standard form of a FOBDE. So to make a standard form of FOBDE, let's look at what we have. So x dy over dx, actually, what you want in a standard form of FOBDE is that there are absolutely none that are multiplied to your derivative dy over dx. So you wanna go and multiply this x, or cross multiply this x right here as the denominator of 5y. Or if you want to be formal, you can multiply both sides by 1 over x. That is the same. So if you want to multiply both sides by 1 over x, this is actually just gonna be dy over dx plus 5y over x is equal to 2x squared y raised to 4 over x. Now our second step would be to find for the FOBDE in y, what we want to have for the standard form is that after we found this part right here, or after we've already established this part right here, we want to add a y. So this is gonna be the second step to forming the standard form of FOBDE, to add a y right here. So where's that y gonna come from? In this part right here. You have a y right here. So you can take that out, and you're gonna have a 5 over x multiplied to it. Now, what is 5 over x? This is actually a function of x. This is now our p of x. Now, the next step would be, so we have y p of x. The next step would be finding y raised to n q of x. So y raised to n q of x. Where's y raised to n gonna come from? Right here. So we can actually take that out. Y raised to 4 times your q of x is actually this part right here. You can actually get that from here. So that's gonna be 2x when we've simplified it. So you have right here p of x, and right here you have q of x. Okay. Now, this is now a standard form of a FOBDE. So this is a FOBDE in y. Okay. Next, we need to find the general solution for this FOBDE in y. So for the FOBDE in y, we're gonna have phi of x y raised to 1 minus n is equal to 1 minus n phi of x q of x dx, where phi of x is equal to e raised to the integral of 1 minus p of x, or sorry, 1 minus n p of x dx. Now, we can find phi of x, which is given by e raised to the integral of 1 minus, our n right here is actually 4. So 4 is our n. 1 minus 4, p of x is 5 over x dx. Now, we have right here 1 minus 3, that is negative 3 times 5, so we have negative 15. Negative 15, we can actually take that out, and then we're gonna have just dx over x inside our integral. Now, the integral of dx over x is just ln x. So you're gonna have e raised to, by the property of a logarithm, e raised to ln x raised to negative 15. Now, by the property of the logarithm, where you have e raised to ln any expression, you're just gonna have to bring down the expression and leave and remove the e raised to ln part. So you're just gonna have x raised to negative 15. Now that we have phi, the next step would be to find the general solution. So to find the general solution, let's just substitute everything that we've had. So we're gonna have phi of x is x raised to negative 15, y raised to 1 minus 4 is equal to integral of 1 minus 4. Phi of x is x raised to negative 15, and q of x is 2x dx. So we're gonna have x raised to negative 15, y raised to negative 3 is equal to negative 3 integral of, so we have x raised to negative 15 and 2x. We actually have two same variables, x, so we can actually add their exponents. So we have negative 15 plus 1. Where did plus 1 came from? So we have actually a hidden exponent 1 right here from x. So you have negative 15 plus 1. When you have same variables, you add the exponents. So negative 15 plus 1, you have x raised to negative 14. We can actually just take out the 2 as well. So what we're gonna have right here is x raised to negative 14. Okay, so we can write this as x raised to negative 15, y raised to negative 3 is equal to negative 6, x raised to negative 14 dx. Now, this part right here, x raised to negative 14, the integral of that can be solved using the power rule, where you add 1 to the exponent and copy the exponent that you have, or copy the new exponent. So what you're gonna have here is x raised to negative 13, since we've added a 1 to the negative 14, and we're gonna just copy that exponent, so negative 13 right here, plus c. So you're gonna have x raised to negative 15, y raised to negative 3 times, and you're gonna have 6 over 13 right here, x raised to negative 13 plus c. Now the next step would be to isolate y. So you can multiply both sides by x raised to 15. You can multiply both sides by x raised to 15, so that this one cancels out. So you're gonna have y raised to negative 3 is equal to 6 over 13 x squared plus cx raised to 15. Now this is actually fine as your answer. You can have this as your answer as already, but if you want to, you can multiply both sides by y raised to positive 3, or multiply both sides by y raised to 4. That's also an option. Okay, so now let's try to solve for c. So that's the next step, is to solve for c, since we are given an initial condition. So to solve for c, we have y raised to negative 3, or sorry, we're gonna have to substitute at x is equal to 1 and at y is equal to 3. Since on our initial condition, this is a function of x, or y as a function of x. So your 1 is actually x and your 3 is the value of y. So we're gonna substitute that. We're gonna get 3 raised to negative 3 is equal to 6 over 13 times 1 squared plus c times 1 raised to 15. Now from here, 3 raised to negative 3 is actually 1 over 27 is equal to 16, or 6 over 13, since 1 squared is just 1, and 1 raised to 15 is just 1. So this is c. C times 1 is just c. So let's try to solve for c. We're gonna get 1 over 27 minus 6 over 13. So I subtracted both sides, 6 over 13. So the next step would be to simplify this. So to simplify this, let us get the LCD of the two. So the LCD of the two is actually 351. Let's try to multiply 27 and 13. We're gonna get 351. And for this part right here, we're gonna use 13. So since 13 times 1 is 13 over 351, that would be 1 over 27. 13 over 351 would be 1 over 27. And for the next one, we have negative 6 times 27. We're gonna get 162. So when we subtract these two, what we're gonna get is negative 149 divided by 351. So our answer for this particular given, or our particular solution, is so the particular solution is given by y raised to negative 3 is equal to 6 over 13 x squared plus, substitute this one, so we're gonna get minus 149 over 351 x raised to 15. So this is our final answer. Okay, so that's all for this video. Hope you learned a lot. Thank you for watching.